Welcome to another episode. Today I'm joined by Bo, who's the technical co-founder at Polymer. Thanks a lot for joining.
Yeah, thanks for having me, Arjun. I'm, really excited to be on this pod. I, follow all the work that you guys do and read all of your posts. So it's a very exciting time to be on and chat.
Yeah, I've been going through a lot of your interviews in preparation for this, and I'm in awe of how you conduct yourself and like how you talk about your protocol. So I'm also like really looking forward to the conversation. So I feel like I know this much about you that you have your background in Web2. You've worked on high performance database systems. You've also worked at Uber. So like from there, how did you decide to work in Interop, and like what's your motivation behind picking this niche to develop in crypto?
Yeah, I think if I step away from all like the technical reasons, and there's a lot of technical reasons because like I'm a naturally very curious person. I like problem solving. I just enjoy the process overall. I think what really stood out to me about the space is just the potential and the potential to really get in at the ground floor and help contribute to these base technologies. I've talked about this before, but it's kind of like hopping in a time machine, traveling back to like the 70s and 80s and working on some of the early internet protocols. And just like having the opportunity is incredible because of the impact. Like in my previous company, or in my previous startup that I helped start out of Uber, the impact was mostly around cost savings. It's like, okay, yeah, we can save you, 40%, 50% of your cloud costs. It's motivating. The company makes money. It's a profitable business. But on the other hand, it doesn't motivate me in the same way that the interop space and crypto overall does. So it's definitely like a motivation thing and scope of impact.
Got it. And then like how did you start Polymer? Because I know there's another founder there, and like you guys have built out a team already because you've been building for quite a while now, right? So what's the vision for Polymer, and like how did that team come together?
Yeah, so I met Peter before I started Polymer. We worked on a few DeFi protocols together. We met through, I guess, a mutual friend circle, so outside of crypto. The way we ended up starting Polymer is I ended up wanting to go into the space first. We actually were members of the Ren community. I don't know if you remember Ren and Ren BTC. We were very active in that community. Initially, we actually we're thinking about building on Ren itself. Unfortunately, Ren kind of rugged, as people know, like the founders kind of left and the development really stalled there. And at that point, we're like, okay, what do we do next? We're planning on building on Ren. Well, let's build it in our protocol ourselves. And some of the initial iterations we went through were, what stack do we pick to build this thing? Because we wanted to build kind of like this hub and spoke model. We picked the Cosmos SDK at the time. A little bit later on, we ended up saying, let's go all in on IBC. So we started off exploring the Cosmos first while designing in our protocol itself. Then we decided on going all in on IBC. And then fast forward a little bit later, we realized that, the best way to scale compute overall is probably with rollups. And Ethereum is arguably the best equipped settlement layer when it comes from a censorship resistance and liveness perspective. Those two properties, I think Ethereum does very well. Then we decided, okay, let's shift our focus to solving for rollup interop. And then that's kind of where we, took this Cosmos thing that we had, or Cosmos SDK stack that we had built, and combined it with OP Stack and built this rollup on Ethereum for interop.
Yeah, I remember like I think when we talked probably last year, you guys were still with the Cosmos vision and mindset, but going through like the recent communications and everything, it's all in rollups and Ethereum interop at this point.
Yeah, absolutely. I think we've like our thesis has definitely evolved. We're not, I would say, like maxes to the point that we can't take in new inputs. So I think over time, as we take in new inputs, it allows us to like craft our focus and where we feel like the problem, where there's bigger problems to solve, and where we think the market is going to go long term. And I think when we first picked, OP and to build a rollup, the like rollup ecosystem was like already popping, but obviously recently it's gotten even more crazy with all these different rollups popping up. So I would like to think that we made a good bet.
I'm also curious on like your thoughts on the vibes in Cosmos and Ethereum, right? Like it's a hot topic right now where some people are saying, oh, Ethereum kind of feels like Cosmos, there's so much fragmentation, but you come from Cosmos and now you're building in Ethereum. So do you feel this as well?
Yeah, I think Ethereum is truly running into a lot of the same problems that the Cosmos ran into. I think the Cosmos folks, just the community overall, is more, I want to say like a little bit like solving problems ahead of time, but they did kind of do that. They solved a lot of problems ahead of time. Even if you look at the design of IBC itself, it's very forward looking. It's trying to solve a lot of like very complex like multi-chain upgrade problems that don't come in to play until you have a complex app that does need this feature. So like you're kind of building ahead, and because you have a lot of teams experimenting building ahead, I know people talk a lot about, oh yeah, all the problems that Ethereum has encountered, someone in the Cosmos has come up with a solution for already. It's somewhat true, but on the other hand, like they have all these solutions in the Cosmos, but there's not enough customers, and there's not enough growth in the number of chains. I think when we first started, we were expecting to see massive growth in the number of Cosmos chains, and unfortunately, that hasn't happened. Although there are very large Cosmos chains, and there's very like I guess like good chains that have picked the Cosmos. Like recently, Story Protocol picked the Cosmos stack. So it's not like Cosmos doesn't have any traction. It's just the scale and speed at which the ecosystem is expanding is a little bit different from Ethereum. And the vibes, I think, now for both are kind of like a little bit mixed as well. The vibe fragmentation is a real thing, I guess.
Yeah, I mean, I feel like the Cosmos SDK definitely has adoption and distribution, but like Cosmos as a chain, the jury is still out on that, right? Like because I feel like anyone who's building a chain or a rollup kind of sort of adopts the Cosmos SDK or tweaks it in a way, but nobody wants to go build in Cosmos as they would probably like 2 years ago.
Yeah, I think my short thoughts on that are that the hub probably should have moved towards becoming more of like a settlement layer for rollups earlier. And you see that model kind of really taking off, where there's a lot of new like settlement layer type protocols. Initia Dimension launched earlier last year, and then like you have a lot of these projects kind of focus on this problem space, because people can claim that Ethereum doesn't have the best properties for settlement or for rollup. So a lot of people are experimenting, and I think that experimentation will continue. So the hub could have kind of front ran all that.
Okay. So like now I kind of want to go into Polymer and like what does your design look like? What are you guys building now? And how does it improve the Ethereum rollup ecosystem?
Yeah, I think we started off, trying to solve very specific technical problems. And more recently, we've kind of zoomed out and tried to think about the space broadly and some higher order questions. So some of the higher order questions that we've been thinking about is, how can we make it more competitive for someone to build an app on chain versus off chain? What are the properties of building on chain that make it attractive? Some of these are maybe not as related to the tech itself, like network effects, platform effects, I guess like the social layer itself. Some of these are very technical. So if you look at from a cost and performance perspective, there's two steps to building an app. In my mind, the first step is how can I make it work? And then the second step to building an app is how can I scale my app? And especially when I worked at companies like Uber, we looked a lot at this sort of thing, because it's not about what the costs are for me today if I onboard you as an infra provider. It's about what my costs are going to be in 10 years when my traffic 10x's, 100x's. And if that chart looks like this and it goes quadratic, then I'm not going to use you as an infra vendor, because I'm going to be like paying out the ass in like, a few years time. And when we look at this, when we take that problem and we look at what the costs are associated with building on chain, we can see that the execution or the compute/block space costs have dramatically decreased over the past few years, and for good reason. There's a lot of teams trying to solve this problem. Solana, trying to bring costs down. You have a lot of L2s trying to bring this cost down, and now that cost compared to the cost of compute in the cloud is getting a little bit closer. So we're looking at tens of thousands. We're looking at a write or the cheapest transaction to a layer 2 when compared to a single write to AWS's DynamoDB. That's cost is about like tens of thousands of times more expensive. So it is a lot more expensive, but it's coming down. It's like the gap is closing a bit. But when you look at interop space, so the space between blocks. So if you look at block space, the individual blockchains, interop space, the space between blocks, how much does it cost to send a message across L2s or send a packet in the cloud? And we compare those costs, then we see that sending a packet or sending a message across two L2s is over 300 or 400 million times more expensive than sending a packet between two availability zones in the cloud. And when you look at that cost and you're like, okay, well, I could build my app on chain, but then when it comes time to scale my app, it's going to cost me hundreds of millions. It's going to be hundreds of million times more expensive than the already expensive thing that I was paying for, which is the compute. And it makes it very not pragmatic for serious builders to consider building on chain for this reason, besides the applications that could only exist on chain.
So like, is this cost because of the design of interop protocols, or is it something else?
Our thesis is it's a bit of both. So if you take a look at a lot of the protocols on Ethereum today, our thesis is that if you want to funnel interop costs, and maybe we can define interop costs as the verification costs of whatever security model that you're trying to leverage, and the data costs associated with that security model. So if you have Merkle proofs for some inclusion proof, if you have a ZK proof, whatever kind of proof that you use, a batch of signatures, for example, could also be considered a proof here. And you combine the two. If you funnel this execution and verification costs to the connected layer 2s themselves, you're going to be paying a premium. If you then offload that cost to like an optimized L2 just built for this purpose in Polymer, then we can kind of cut down on those costs, especially at this point when a lot of these L2s, not only is it maybe perhaps a little bit more expensive, they might be using like settling more often to Ethereum. There may be certain properties of the protocol that already keep their base costs up. They're also making, in some cases, 98% margins on that compute. So you're paying a higher base, and you're paying for the 98% margin that profit margin that they're making. If you take all those costs and you offload it somewhere else, it's at least 100x reduction. If you get what I'm saying. So that's kind of our goal. That's why we're working with EigenDA. Our ultimate goal is we want to get these costs for different levels of security down to as low as possible, as well as working on the latency bit, which we can talk about soon.
Okay, so as I understand the different designs of interop protocols today, there's point-to-point, which is kind of adopted by layer 0 hyperlane. There's like the hub and spoke model, which Axelar has that, and then Wormhole kind of has a similar design, but they have validators. And you guys are introducing the hub and spoke model, but the hub is basically a rollup L2, right? Like that's the major difference. And you're saying that because it's a rollup L2, it's cheaper for you guys to verify the compute across rollups pretty much. And the other guys can't do it at the same rate because they have like a totally different design. It's either point to point or like they have their own validators to pay off in the hub and spoke model.
Yeah, exactly. Like without getting into too many of the technical minutia, it's just the cost basis. The cost basis of having all your execution, all your data flow through the respective L2s, or have all this flow through an alternative layer 1. Your cost basis is just a little bit higher. Or like in Wormhole's case, where there's a lot of infrastructure associated with their product, your cost basis is going to be higher. So to us, we think a lot about what the base cost is, and then also think about the margins as well. In terms from like a business perspective, there's also the angle of latency. So when you look at latency, when you compare kind of this model to like the point-to-point model to the L2 hub and spoke model that we deploy to the L1 hub and spoke model that an Axelar would deploy. And in Wormhole's case, they don't have consensus, but they also do have a Guardian set that is distributed. There is some like network latency overhead there. And then you look at a lot of these layer 2s that are coming up, like Mega ETH that had 1 millisecond block times. Then you start to see that if you have clusters of Mega ETH like rollups with like 1 millisecond block times located maybe like not in the same data center, but like in data centers in the same region, then you can see that there's going to be like a lot of traffic potentially flowing through these at really high rates, and then you're kind of minimum bounded in terms of latency with a layer 1 because you have consensus. Or like minimum bound in the network latency between distributed nodes, because you have to go, geographically from the US to Europe to Asia. Each one of those hops is going to be at least hundreds of milliseconds, and you're kind of lower bounded there. The point-to-point protocol is a little bit better in terms of latency. They can inherit the latency of the rollups that they live on, but then there's also like the cost associated with it, and also the scaling costs as well. Which for a lot of security models, when you like scale the number of connected chains and how densely connected they are, you get this like n-squared verification scaling property where it can get quite expensive. And we've kind of like done some back of the envelope math where if you want to, let's say, verify even like something simple like sequencer signatures with 1,000 rollups connected at 30-second latency, you can get into like the tens of millions of dollars per day in terms of overhead. It can get very expensive.
Okay, so basically, like the rollups of tomorrow, like Mega ETH, at their scale, it's impossible to do it in a cheap way in the current designs, right? And
Yeah.
so, just another point on the cost side of it, I feel like this has not gone unnoticed, right? Like I feel like there's a trend in Interop where each protocol has a modular security stack where they kind of try to build a XY graph with a cost and like cost and flexibility, or like cost and security as the 2 points, and a protocol building on top can kind of choose within that spectrum, right? So they could technically choose a cheaper option. So do you guys have a similar setup, or do you have a default that's just cheaper because of the design?
Yeah, so we do have a default, and the rationale for it is in the highest trust that's achievable at a certain latency. So because we're focused on lower latency transactions and trying to get that number down, because we think long term that's what's going to make building on chain competitive. If you build a Web 2 app, you expect that if I build a bunch of microservices, that they will be able to communicate with each other both quickly and cheaply, and these builders will have the same eventual expectation of building on Web 3. So we're trying to get to that point at certain latencies. So I see the finalization of a rollup, or the settlement of a rollup, in 3 phases. You have this initial phase where the sequencer is producing blocks, but the layer 1 doesn't know about these blocks. This is kind of I think OPStack calls it the unsafe period. I'm just going to call this the local ordering period. So you have some local ordering guarantees made by the sequencer itself, no global guarantees yet. The second the sequencer has published that data to the layer 1, whether it publishes to altDA and then kind of like the hash of the layer 1, or they publish to layer 1 blobs, either or, that ordering guarantee now gets promoted to a global ordering guarantee. And you can kind of see this property of when there's only a local ordering guarantee, even if you add additional validity mechanisms or verification mechanisms, it doesn't improve the security model. You always have to trust the sequencer. So I think from that perspective, we're like, if you're going to go fast, if you're going to go like seconds, tens of seconds, milliseconds in some cases, you can only trust the sequencer. Trusting the sequencer is the best possible validity mechanism, the best possible ordering mechanism. However, once the sequencers publish this data, which is, some rollups, it's a few minutes, some rollups, it's like an hour. So there's a really big time range here. But once they have published data, this is when you can like leverage ZK proofs for validity. Like if you want to use like OP succinct, turn your rollup to a ZK rollup, gossip these like proofs P2P or something, you can have these designs. It'll cost you, but you can have these designs. But that's when validity comes in. If you add an attestation committee, like a Lagrange state committee, which adds crypto economic security plus the security of a number of nodes, that also adds additional security. Or if you want to use a fraud proof, that's also fine as well. But if you're in the other side of the spectrum, the sequencer side, which is what we're focused on, the security model that we leverage is sequencer guaranteed security. So we have a verification mechanism that parses the sequencer signed execution payloads of connected OP-Stack chains. This is very similar to Helios. I know Vitalik called out Helios for, I guess, like more trustless RPCs, but we're leveraging the same like verification mechanism for connecting to OP-Stack chains at very fast latencies.
And like, does your rollup has a sequencer or not?
Yeah, our rollup has a sequencer as well. It's I'll say like underneath the hood, it's very much like any other OP-Stack rollup, or very close to every other OP-Stack rollup.
Got it. Makes sense. And then you guys are also using EigenDA, right? So where does that come into the picture?
EigenDA from our perspective is a cost. It increases our interop bandwidth, so the amount of data bandwidth that we can push through our system, as well as reducing the cost of that bandwidth. And to give you an example here, when we connect to a base or an optimism via the sequencer client, we're actually processing all the transaction data from these chains. So what's happening is, if we were to push this data throughput through Ethereum, we would create this ever-growing, quadratically increasing amount of data that's flowing through, or data explosion that we flow through Ethereum. So it's actually impractical for us to do that, because as we stream like block to block, like we're going to aggregate all this block, we're going to double that data. So if we push it through EigenDA, there's more than enough bandwidth on EigenDA to support our use case, and we're able to do so cheaply. So we can add a very very large number of chains I think I made a presentation that I presented on with the Rollup, talking about the number of chains that we can support on ETH and I think sequencer client. I think it was roughly around like 4 to 5 chains. And then I recall on EigenDA today, like not even their, when they hit their goal of like 1 gig a second, they're at 15 megabytes a second today, that they're already able to support hundreds or thousands of these chains for us. So yeah.
Got it. So it just feels like you've taken a lot of design decisions based on keeping it lightweight, keeping it cheap for the builders to come and like build applications on top that can scale for the future, and also for you guys to actually be able to scale and connect to the widest number of chains, or like the most number of chains.
Yeah, exactly. I actually like the way I kind of see the era of Interop, and let me know if this makes sense. So I'm drawing an analogy to like the L1, like the different L1 eras that we went through. So initially you had, when Ethereum first came out, you had a lot of these like alt L1s that also came out doing some experimentation. But in that initial era, it was more of like, let's make it work. Can we run a program, like a smart contract or this smart program on chain, on a blockchain? And then after, we made it work and people kind of realized that, especially during DeFi summer, that when there's demand, block space is really expensive. This is when we kind of moved on towards like a performance era of L1s. They're like, how can we bring this cost down? How can we do more TPS for less? And there's been a lot of experimentation in that area. And my thesis, or our thesis, is that we're going from a place where let's make Interop work. Let's be able to send a packet at all between 2 chains, to how can we make this performant? So now I think we're going to enter this performance era, or golden performance era of Interop protocols, where hopefully we'll see that gap, that hundreds of millions of times like cost multiple, go down hopefully to tens of thousands or even hundreds of X. And then at that point, like now building on chain becomes more palatable for folks.
I think that definitely makes sense. And even like for the simplest use case, like bridging, even something like Stargate, which is built on top of layer 0 and uses messaging, is going through something similar, right? Like initially the cost of messaging was higher, such that their fees became higher, and they were like uncompetitive on some routes. But then with layer 0 v2, they've kind of brought the fees down because they have much more order flow and they need to be able to send many more messages, right? So you're right in saying the demand for order flow and for interop kind of demands us to build more performant interop systems, and you guys are going in that direction.
Yeah, absolutely. And the other angle that we see, and this is a little bit more longer term, so it's going to require a little bit of imagination to imagine what this future is like. I think one of our other theses is that in the future, a lot of app primitives will be built as like rollup templates. So when I think about like traditional database systems, I think about systems that, sure, I can spin up a single node of this database, a single Cassandra node, but there's also tooling available that if I want to spin up a cluster, I can spin up a cluster. If I want to scale that cluster, I have tooling for that as well. And it's not like each one is a different type of database node. Each one is still that same type of database as a Cassandra node, but I'm leveraging it at a much higher scale. So I think a lot of these infra app primitives, or infra building blocks, or infra rollup building blocks, like ours, in the future, we'd expect folks to be able to spin them up at will and be able to spin them up in different contexts, different numbers of these rollups, and be able to leverage them across the board. So when I think about it like this, like maybe, the right analogy for what Polymer is building is somewhat more similar to like a messaging queue, like an Apache Kafka in Web 2 that can be spun up within a rollup cluster, between rollup clusters, across like a subset of rollup clusters, and people can spin them up and set them up however they want. And I think that's kind of like the end goal of where we're probably heading in like the long-term future.
So I think like before our recording, you shared a diagram with me, because one was basically like connecting the different rollup clusters. The second was expanding the rollup clusters, and there was a third point, right? Like I'm kind of missing the third point. So what was that?
We have 3 areas. So we have at the top we have expansion. On the left we have concentration. On the right we have connection. And the idea is, how can Polymer both work within rollup clusters, between rollup clusters, and across rollup clusters? So the first point is that we built Polymer so that it's able to expand the size of a rollup cluster. For example, we built it so that we can extend the superchain native interop core standard and be able to support those interfaces across a much larger set of chains. So expansion. We built Polymer so we can connect rollup clusters together, or connection. And we also built Polymer to be able to bring rollup clusters together from a latency perspective or concentration. So we wanted to hit all these 3 points and work across or be a complementary piece to all these other technologies in making the interop space as a whole just more efficient.
Got it. I feel like the newer teams have this advantage, right? Like they can look at the ecosystem from a wider perspective and just build new solutions from scratch. Whereas even though some of the existing teams have distribution, but they don't have this advantage of like a wide view of the ecosystem, right? So just how you've framework the rollup clusters, I'm not sure if all of the teams even have that sort of framework. So I feel like that's pretty cool.
Yeah, thank you. I mean, it's we're not yet burdened, so we're able to kind of just explore and experiment and do kind of like a lot of like forward-looking research, but we're also making bets. So I think when we make these bets, we are betting on that this is the future that will become. Because if you end up in a future where there's not that many rollups, then our thesis kind of falls flat.
I mean, like these signs are positive because we just saw Uniswap launch Unichain, and it just feels inevitable that every app with scale, like you mentioned earlier, will somehow have their own rollup or a chain or an ecosystem, right? So it feels at this point, it feels like a good bet to make.
Yeah. We're definitely feeling good about the direction right now. But there's a lot of ups and downs. At one point, we felt good about being the cosmos. So, so things can change very quickly. I think as a startup, you just have to like be agile to these changes.
Okay, awesome. So like you guys are now close to your mainnet launch, right? So what can you tell us about the mainnet? When does it go live, and what can people expect when it goes live?
Yeah. So before we talk about the mainnet, I do want to spend like a little bit of time talking about like rollup security, like how we think about it, how we model it, as kind of like a segue into our kind of a mainnet announcement. We thought a lot about how rollups work, and we really dug into the source code and implementation details of rollups. Like we didn't just take, oh, these rollups have these properties as at face value. We really dug in to see like how each of these mechanisms are implemented, and how can we build around these mechanisms to make interop or cross rollup communication safer. And we broke it down into a few different rollup stages. So these stages actually map to the security guarantees of a chain. So there's a few security properties of a chain. There's 2 liveness properties: censorship resistance, the ability to produce blocks, and or ledger growth. And there's 3 safety properties and reorg resistance, data availability, and validity. And when you look at the properties of rollup safety that is being deployed today, most in our protocols only talk about one of these properties, which is just validity. And validity is somewhat meaningless without these. Well, not meaningless, but like it's a much weaker guarantee without all these other properties involved. And when we looked at this, we realized that at the different stages, each of these security properties comes into play. So in the first stage, the local ordering guarantee, that actually affects censorship resistance and the liveness of a rollup, because of how forced transaction inclusion works, and the forced transaction inclusion mechanism guarantees censorship resistance for the rollup. But it also affects the ordering of the rollup. And if you get that part wrong, you can end up with really large reorgs, which is not good. And we've seen some of these operational like reorgs, not related to this, but related to data availability happening, which I think long-term, as we have a lot of these rollups, I think operational reorgs will happen much more often than a reorg attack on the base layer. And then you have the data availability property, which is inherited at when the global ordering is initially achieved, once like data has been published. And then you have like validity that can kind of come in and be overlaid on top of that period. And then you can have this like global ordering that's not finalized. And at some point when that data has been finalized, then you have this finalized global ordering or view of the rollup. And we kind of call each of these phases like different stages of rollup security. So we try to do like a L2 beat like model. And it's just a proposal, but we're trying to motivate people to think about these things. And we start by thinking about the different stages in terms of where we are today, which is every interop protocol provides some validity guarantee. So we just call that stage 0. Okay, and we think about like how can we move on from this? And at stage 1, we define, okay, maybe we can have rollups also provide a local ordering guarantee, and we call that stage 1. And then for stage 2, we want rollups to be able to provide a global ordering guarantee, which is a very strong guarantee that's layered on top of the validity. So each of these steps adds additional security and brings in the additional security properties of the rollup itself into the play and into consideration when we're talking about Interop. So that's kind of the, I guess, a summary of the ETH research post that I published, I think almost a few months ago now, called like modeling security for cross rollup interoperability.
So like in stage 1 and stage 2, what is the role of Interop protocols? Because right now it sounds like the emphasis is on rollups to build some of these native guarantees and standards. But what can Interop protocols do in this direction? And like, how are you guys pushing the space?
Yeah. Well, maybe I think I lost you again, Arjun. Okay, are we back? Sorry, I think the internet was... Okay. So the question was, what does stage 1, how does stage 1 and stage 2 guarantees work in the context of Interop protocol?
Yeah.
So for stage 1, which is a local ordering guarantee, we published an RIP, Rollup Improvement Proposal, RIP 7789, around a spec and a proposal for how you can essentially create a dependency of cross rollup transactions on the shared L1 history across different rollups. And in that, we define a few safety invariants that, if enforced, can improve the quality of cross rollup communication. And in that RP, that kind of covers the local ordering guarantee, or stage 1 of this rollup security model. Stage 2 is the second part of the range, because like RP 7789 only satisfies the range up until when data has been finalized on the L1, and it kind of overlaps with stage 2, where there's this like global ordering guarantee that's kind of enforced, and then you're going to have to enforce that by checking to see if that data has truly been published for a rollup, and this ensures that the validity guarantees, depending on these more secure validity mechanisms, can be achieved. If the data is not published, you can't create a fraud proof. If data is not published, you can't create a zero knowledge proof.
Got it. And then the onus is on the rollup teams to kind of adopt these invariants, right?
So the only thing that the rollup teams need to adopt, especially for RP 7789, is that they need to track the L1 origin, or the L1 block hash or history on the L2. Every L2 block, from my perspective, is a combination of layer 2 inputs and layer 1 inputs. Layer 1 inputs involve deposit transactions, and it also involves force included transactions. Layer 2 transactions include all transactions that are submitted to the sequencer. These 2 inputs are combined to create a layer 2 block. So the requirement on the rollup side is that when they combine these inputs, that they should also include the L1 hash of the block that they derive these inputs from. Some rollup frameworks do this, some rollup frameworks do not, and we're trying to get some consistency around this. The rest of the RIP just can be implemented within smart contracts, and it's actually a relatively simple check. We have some pseudocode and a spec for it.
I mean, yeah, any sort of standardization across rollup clusters would always be welcome, right? So I feel like you guys are again taking the right step in a good direction, just to get some standardization for Interop protocols and for rollup clusters. So again, that's awesome.
Yeah, and excited to, happy just to contribute to like Ethereum overall and the rollup space overall, broadly speaking, outside of the product that we're building.
Okay. Coming back to the mainnet now, right? Like, what's the timeline, and what goes live on the launch day?
Yeah, so we're going live with a small set of chains, but we're planning on expanding very quickly. Due to our chain expansion mechanism, we're planning on being able to expand to cover pretty much the entirety of the OP Stack landscape that's live within a few months from launch. And we're actually planning on announcing mainnet, depending on when this is actually aired, within a few weeks. So very, very soon. Like you just we can all prep for the announcement. And it'll be somewhere around like DevCon as well. So we'll be at DevCon. Announcement will be around then. So feel free to reach out to us via socials, or just come find us at DevCon. I'll both be in Chiang Mai and Bangkok.
And then just like the last question to wrap this up, what would be your pitch to app developers to like build on top of Polymer? Like, what would be the 3 things that you would point out that you guys do better than everyone else?
Yeah, I think that the main things are going to be latency and cost. And would say like ease of expansion or support for some of these like more native interop standards. So if you're looking to like use superchain native interop on a bunch of different chains and like their native interfaces, so if this is the basic interface for verifying logs, then we would extend that. If you're looking to use IBC, we also support IBC, and all of our tech is built on IBC primitives. But the top line things are going to be performance and cost. If you care about latency and you care about cost, we're trying to make a very competitive product just in those two areas, trying to bring those costs down for developers. Like I mentioned earlier, I think the North Star is how can we get to a point where we can close that gap between cost of sending a packet in the cloud and cost of sending a message across rollups. And the closer we can get that gap to close, the better place overall that the space will be in. So yeah, like those are the main things.
Awesome. Thanks a lot for like explaining what Polymer does and how you guys are thinking about the ecosystem. I'm really looking forward to the launch because I know you guys have been at it for a while, and it's time to go on mainnet, right?
Yeah. I will say like the initial launch set is going to be a little bit small, but we'll be expanding very quickly to additional chains. And our protocol is kind of in different layers. So we can establish connectivity to a chain. You can have like basic messaging functionality. We can also like add in IBC messaging functionality as well. These are all layers that we can stack on top of each other.
Awesome. Looking forward to seeing you in DevCon and also looking forward to the launch. So all the best.
Yeah. Thanks, Arjun.